This question is checking to see how much we understand about databases and SQL, or some people call it SQL. It's the same thing. So we've got some definitions just here, and we need to match them up with certain words. So before we jump straight in, it's worth saying that if you want any more information, then there's a YouTube playlist which will give you an overview of databases and SQL, and then guide you through all the things you need to be able to do for your exam, with some links to examples so that you can try this out. So it should make a lot more sense. So there should be a link to this playlist in the YouTube description. So before we match up the keywords and definitions, it's worth looking ahead to the next question because we've got an example of a database. So let's look at this to work out what the words mean. So in this relational database, relational means we've got more than one grid of data, and we call each grid a table. So we've got a table called class and a table called teacher. And in a relational database, we've got some sort of link between the data. So let's have a look at this database. Inside the class table, we've got 4 different fields. So we know that we can find out a class ID, the size of that class, when that class is taught, and who teaches it. And we've got 8 different records, 8 different rows in this table, and each record we can find out data for that class. So in each row, all of this data is linked together. So for example, Comp B10 is the name of a class, 19 people in that class, taught on a Friday by whoever TUR is. So at this point, this is where we can find out that there's a relationship in our database between our class table and our teacher table. Because if we want to find out a little bit more about TUR, we can look up the teacher with that ID, find out their surname and what room they teach in. So it's a simple database with a relationship between the two tables. So let's go through each of these definitions. A row of data within a table. So a row is any of these lines going down, and we call a row in a table a record, which is E. So for 1 mark we write E in here. Uniquely identifies a row of data. So in each table, you have to be able to tell each record apart, so that if you wanted to edit one later, you could say to the database which one you want to edit. So in our class table, the class ID is different for every record, and in the teacher table, the teacher ID is different for every record. And we call the field that is different the primary key. It's the one, you could argue it's the most important field. It's the one that must be different for every row, every record. So the primary key just here, and it's the primary key that's used to define our relationship. So here, our teacher ID is referenced in the class table. So links between tables. We know that there's a link between our class and our teacher. In a relational database, we call that link a relationship. It's just saying that one table is connected to another table. So links between tables is a relationship that's F. Used to speed up searches. Well, in our small database here, we've only got 8 classes and 3 different teachers, but in reality, say the database that Google sits on top of will have billions or trillions or even more records in their databases. So the computer needs to be able to search through the database extremely quickly, and it does that by storing certain fields in as fast storage as is available, and so the database can say which the most important fields are by calling them indexes, and they're used to speed up searches and used to speed up sorting. So an index is used to speed up your searches. Okay, so if any of this hasn't made sense just yet, remember, do have a look at this Introduction to SQL playlist. The first video will give you an overview of databases and the theory behind it, and it'll go through searching, the second video, searching across relational databases, changing data, adding data, and deleting data.